Hi everyone and welcome to this new video. In this video I want to tell you that the new release of Phrack is currently out. Now for those of you who watch my Why 2025 video, well, you actually know that here I have a physical release of Phrack, of the latest release, but now it's actually online for everyone, so you should go and definitely check it out. So here we can find the introduction from the Phrack stuff. So, Hacker Revolution. For 40 years, Phrack has published papers that have reflected and shaped hacker culture. The knowledge shared in Phrack has laid the foundation for many fields of study, providing insight, a shared language, resources and tools, as well as context and history. Phrack is written by hackers for hackers and offers a glimpse into the world just beyond what most people see. So Phrack is both a technical journal and a cultural document. Like all designs, it represents a snapshot of the scene at the time. We share not just our discoveries, but the stories of how we came to know the things and the context in which we existed. Over the past 40 years, hacking has evolved, splintered, and mutated into a variety of forms. Phrack has documented many of key innovations in hacking since its first issue. From showcasing ways to manipulate the phone system and other large computers, to pioneering vulnerability scanning, to generalizing security concepts such as buffer overflows, return-oriented programming, and heap exploitation, to bringing it all together within complex ecosystem that seemed like fantasy in years past. So the hacker ethos remains the same: be curious about your world, make do with what you have, and show how things can be better. So a great release of Phrack. I suggest you to just read it. Now in this video, I would actually read with you an article which I just finished reading, which is this Guarding the PHP Temple by Mr. Me. So this is a fun article. I find it cool. So I just wanted to help you to learn, to read and learn with it. So basically, this was written by Mr. Me. And in this article, he showcases a vulnerability that he found while he was analyzing a PHP code base. So basically, this is a PHP code base that was built with Catalyst Sentinel. Now, if you go into the website, it says a modern and framework agnostic authorization and authentication package feature roles, permission, custom hash algorithms, and additional security features. So this should be something that is for authorization and authentication that is framework agnostic. So it doesn't really matter the framework you use. You can always use this to deal with authentication and authorization. And now we are presented with this PHP source code. So what does it do? Well, here we are including some configuration. Here there is a renewal function that just renews the current session. Here we perform a check on the user, like if the user is probably logged in, I suppose. We get the email from the user in the current session, and if we want to log out, we actually log out the user. Otherwise, we're just gonna renew our session here. We do the renew session here. Otherwise, if you're not currently logged in, so if there is no session, we're gonna check, wait, does the user want to log in here? And if the user wants to log in and it has set up the username and password, we're gonna authenticate with the provided email and password. If everything goes well, we're gonna log in the user. Otherwise, we're gonna just say, look, credential failed. Otherwise, the user is not logged in. So basically, if the user session is not there and the user does not want to log in, you're just not logged in. At the end of this thing, what we can assume is that, okay, at this point, we do have a user session, and so you are logged in with this particular mail, basically. So that is the idea. Now, okay, now do something. So what's the idea here? Well, if we check, so it's like he says, okay, look at the proof of concept. Here we are not logged in, so we are not currently logged in. Then we perform a login with some John Wick credential, John Wick at example foobar. And here it says, okay, 200 okay, here you get your PHP SSID. And then we find here we get the cookie, from this request you get the authentication cookie. And then this authentication cookie is used in successive requests to be logged in, basically, because now we have a session, so we can use it to do stuff. And once you are logged in, it's gonna renew your session when you sort of like use it. As you're using the session, the renew session is gonna be called, and it's gonna renew the session, and it's gonna generate new PHP SID, basically, new session IDs, and it's gonna be saved in the database. So here we can see it's a MySQL database. There is a table called persistences that contains the ID, the user ID, the code, and the date in which it was updated. As you can see, every now and then we have the update. Now, the actual exploit, I mean the actual vulnerability is this. If you use this particular cookie, which is called Catalyst Sentinel equal 5, you are actually authenticated. So why did this work? Well, it worked because one of these cookies, actually the last one in the session, started with a number, specifically with the number 5. So here you can just put 5 and boom, you are in. This basically allows you to guess the cookie value for the session. So what is the idea? Well, the idea is that this vulnerability is known as type juggling vulnerability. Why? Because the cookie, technically, we want it to be a string. I mean, not necessarily, but most of the time we expect a cookie to be a string value. Now, in the database, the cookie itself is a string. However, in MySQL, when you compare a string with a number, MySQL is actually going to convert the string with a number if the string starts with a number, basically. And so you're going to have comparison between two numbers. So this is all to say that when this thing is considered as an integer, we do not see the entire string, we only see the 5, and therefore we can easily guess the cookie because we just have to guess a single digit. So the number of characters we need to guess becomes drastically lower. So this is called type juggling because we are making like the engine sort of like do conversion between types, like we are playing around with the types. So what's the idea here? What's the root cause? Why can we just authenticate with this? So here the things to understand are two. Why this particular name as the value of the cookie, Catalyst Sentinel, and why this particular value? So first things first, if we cast this as a signed integer, we obtain 5. Because when a string is compared to an integer, MySQL tries to cast a string to an integer before doing the comparison. And this, of course, can lead to surprising behavior. And this especially happens when the string starts with a numeric prefix, because we will have a number. So for example, in this case, here it's gonna end up as 5. Probably if here there was like 52, here we would have 52. So that's basically the idea. Now, the question though is that, wait, how can the PHP code actually give a number to the database? How can the database perform a query based on the number? Because basically here we are comparing, it's like why, okay, in terms of query here, if we make a query where code equals 5, we obtain this thing. Why? Because internally MySQL performs this type juggling. So MySQL is going to compare code integer with the number here. It's going to convert this into an integer. So it's going to have 5 equal 5. It's going to say okay, and it's going to return this entry. So now the question is, okay, but why from the PHP do we end up doing this kind of query? Because if in this query here we put code equal with the string 5m6 and stuff, this thing would not happen. So we need to understand how come the PHP application creates this particular query. So how does that work? So inside the code here, we have the check function. So remember from before, if we scroll up, remember that here, the function that checks if the user is actually logged on is this sentinel check. So the sentinel check performs the check on the to make sure that the user is logged on. So this check, how is it performed? So this check is performed as follows. So first we make sure if the user doesn't exist, if the user is different from null, so if it does exist, we return the user object, which means that the user is currently logged in. Otherwise, we keep going, and what we extract is the code. And we extract this code through this method, this persistences check. So we extract the code. Once we have the code, we can extract the user by the function find users by persistence code. And at that point, once we have the user, here we do another check, which is not that interesting, and then we return the user. We return the user and we set it into this object. Into the in this case, it would be the the check method of Sentinel. So I suppose this is like a Sentinel object or something. Yeah, this Sentinel object, we put it into there. Okay, that's good. So we have this situation now. So now at this point we have to understand these two things. How is this code retrieved? Okay, and how is the user retrieved based on the code, right? So we are doing a root cause analysis. We are going inside the code. So this check does two things. First, we consider the session. If the session is active, we return it from the session. However, in this case, we are not logged on, so we don't really care about the session. And so we're going to use the cookies from the user, which are attack controlled. I mean, the user can control that kind of input. Now, we don't care about the session because we don't control that, but the second call actually grabs the cookie. So if this first one gets something, then okay, we return that code. Otherwise, we return the persistent code from the cookie. Now, since we implemented Sentinel using the native interface without Laravel integration, so here it talks about the fact that this library can also be integrated with Laravel, which is a framework for creating PHP application. But in this context, we are using Sentinel without Laravel. So basically, it's going to use this function in native cookie.php, and this native function, look at this, it's going to say get cookie. It's going to check if the cookie is written into the HTTP request, and if it is, it grabs it from the request. Now notice that here it uses this option name, and the name can be configured by the user, that the default name is the Catalyst Sentinel. So at this point, we actually answer one of the questions that we had. And the question was, why was the cookie named exactly in this way? Why was the name of the cookie exactly Catalyst Sentinel? And this is because the native interface of this library uses this particular name as the default configuration. Of course, you can configure that however you want. So, but even more interesting is not only this one, the name of the cookie, but also this other thing, this call to JSON decode. Now, basically the idea is that if we have a value, this value is going to be JSON decoded, right? And why is this interesting? Well, it is interesting because the fact that the value passed by the user goes through JSON decode actually allows the user, allows the controller to control not only the value that we are passing to the backend, but also the type that the backend will use to handle that variable. Like, look at this. If we do, for example, a JSON decode of the string 1, like if you just give a string 1, it's going to give us a string. However, if we just put 1, that's it, it's going to give us an integer. Now, typically a cookie by itself, when it is parsed by PHP like this, I believe this thing is a string by PHP. However, this JSON decode allows us to transform that string into an integer. And this becomes critical for the last point of the exploitation. Why is that? Because so remember, this is how we get the code. So at this point, we've got a code and we control the type of the code. So this code now is an integer with an attacker controlled value. Now at this point, this code is going to be used to find the user, right? With this find user by persistent code. And how does that work? Well, it creates an abstraction over SQL, like typical of this kind of libraries. And this abstraction creates a query where the code value here were code with this code value here. And this where, like this abstraction takes into consideration the type of code. If the type of code is an integer, it's going to create an integer query. Otherwise, it's going to create a string query. Like, look at this. So basically here is find user by persistent code. This is the function. This is implemented by this find by persistent code, which is this one, find by persistent code. And here we have the query itself. So this is gonna query the database, and it's gonna get the first. Here first, okay, yeah, it's gonna get the first. At 8, a query is built, so it's just gonna get the first output of the database. And this query is built using the Illuminates Query Builder API. And this API takes into consideration the code type during construction. So as I was saying, if this code is a string, we have this string, otherwise we have 1237. And since, so basically the idea is that the code is generated with str random32, which can include numeric values. So you just basically you have a session. This session at some point will generate a random string that starts with a number, and you can spoof like you can just steal user sessions like this. Basically, you don't need to spoof; you just steal the user session, because you can like just guess it on your end through this technique. So it's a very fun thing, I would say. It's a fun chain. It's not trivial. Like many things have to be in specific ways in order for this to work. But yeah, basically that's the idea. So at the end of the day, mitigations. Okay, there's a lot you can do to prevent this. For example, if you use Laravel plus Sentinel, then you're not affected basically. And this is because in the default thing, you don't do the JSON decode, I believe. So look at this. This is because the code that uses the Illuminati cookie class, the Illuminati cookie class does not use JSON decode. So here, there are a bunch of things that are chained together. So first of all is the type juggling in MySQL, which means that if you have such a string and you cast it as integer, you have 5. And when you compare a string to an integer, MySQL is gonna change, it's gonna cast the string to the integer, right? So that's the first thing that has to happen. The second is the fact that we perform this JSON decode over the cookie value. And this JSON decode allows us to control the type of the value to make it an integer, basically. So one thing that you can do, for example, is not use JSON decode, so that you always have a string, and so that when you create the SQL query, this query is always going to compare a string to a string, so that type juggling does not happen, basically. Now, the other mitigating factor is that in newer version of the Catalyst Sentinel library, the code uses type hinting. So what does it mean? It means that it actually declares in a type hinting way that the output is a string. So this means that the interpreter is going to know, okay, here I get a string out. But of course, to use this type hinting, you need to use a newer version of PHP. I mean, newer in the sense of PHP greater than 7.0. I'm not sure what is the latest version of PHP. Maybe it's not that new, but like companies, they are so slow at upgrading that, I expect a lot of code bases to use all versions of PHP. Basically, that's the idea. And so in this case, here you have type int of string. So you know that regardless of how you get this cookie, you're gonna type int string, like you're not gonna have a number. So basically that's the idea. And also, he writes, Mr. Me writes, I would recommend that MySQL addresses the type juggle in case other ORMs dynamically generate SQL queries, and factor in the value types when generating the where clause. So this is another thing that is useful to understand. So this vulnerability was a real edge case and resulted from a comedy of quirks, errors to obtain a powerful authentication bypass. Now, there are caveats though, because the attacker will need to wait for someone to log into the target system before they can run their attack. And additionally, the attacker will not know which user logged in. As such, it is ideal to chain it with a code injection that is user independent. And then he said, in the future, I may detail the code injection component as it is equally interesting and bypasses some built-in mitigation. So there's probably going to be some other vulnerabilities in this. I'm not sure if it is in the library or in the analysis that he did, because so like he said that he cannot disclose the full details, But since the bugs are not actually within the application logic, but rather an outdated third-party library, I figured what the hell, and I can talk about some of it. So probably this is not the full chain. This is just one of the issue that he found. So very interesting article about type juggling, about the ability for the user to control not only the value but the type that is used then to perform an authentication bypass. So I hope it was an interesting read for you too. Go and read the full article. Go and read other articles of Phrack. Extremely interesting. And that's it. Thank you very much, and to the next video.